Hello dear students. In unit metallurgy, concentration of the ore. We know what is meant by concentration. Concentration by which you mean removal of the impurities from the ore. We have many concentration techniques available. In this session, let us learn about electromagnetic separation and leaching. First of all, electromagnetic separation. Actually, this is based on the difference in the magnetic properties of the ore and the impurities. This method, they say, is applicable to ferromagnetic ores. Example, say iron, cobalt, nickel and most of their alloys. These are ferromagnetic in nature. Materials which form permanent magnets. So these are all the a little bit of explanation regarding ferromagnetic ore. Using this electromagnetic separation, tin oxide and wolframite, these two can be separated. In short, I can say, using electromagnetic separation, we can separate a magnetic particle from a non-magnetic one. Say for example, let us consider this example. Tin stone ore. This tin stone ore is usually non-magnetic, SnO2. This tin stone ore contains wolframite, FeWO4, as a magnetic impurity. So between these two, one is magnetic and the other one is non-magnetic. Therefore, we can separate using electromagnetic separation. Likewise, we have some magnetic ores such as say pyrolusite, chromite, etc., which can be separated from siliceous impurities, which is usually non-magnetic in nature. This electromagnetic separation comprises of a diagram. In this diagram, you could observe there is a hopper in the top, which is placed to keep the crushed ore there. So a crushed ore is poured onto the electromagnetic separator. So we have a belt. There are two rollers. So these two rollers are connected by means of a belt, or I can say a belt is moving over between two rollers. Between these two rollers, one is magnetic in nature, whereas the other one is non-magnetic. Okay. So here, magnetic ore will be attracted by the magnetic roller, and as a result, it falls as a heap close to the roller, whereas the non-magnetic part falls away from the roller. That is, magnetic ore will be attracted by the magnetic roller, and it falls as a heap very nearer to the roller, I can say. Whereas the non-magnetic material, it falls slightly away from the roller. So in this way, we can say explain the process of separation of substances from which one is magnetic and the other one will be non-magnetic in nature. Next one is called as leaching. So now this leaching is again another one concentration technique, but there is a slight difference that you have to understand. The previous concentration techniques we have learned, that is say froth flotation process or gravity separation process, or even this just now what we have learned, that is electromagnetic separation. These methods are actually physical process of separation, whereas this leaching, what we are about to discuss now, is actually a chemical method, and that's the difference that you have to understand. First of all, what is meant by leaching? See, leaching by which we mean, it's actually a process. Here we are adding a chemical substance. What this chemical substance will do, this chemical substance will dissolve the metallic ore present, whereas the impurities present in this particular ore is not soluble. It is actually, it falls down as an undissolved substance, or it just, I can say, these impurities are insoluble in that chemical reagent. So I can say, using this process, the metallic ore can be concentrated by carrying out a chemical reaction with a reagent, which would dissolve the ore, but the impurities remain undissolved. So the chemical substance which I am using for leaching process will dissolve only the ore particles, that is the metallic ore particles, whereas the impurities present in that particular ore remain undissolved. So this is a fundamental principle involved in leaching. Now, depending upon the chemical reagents which I use, there are different examples for leaching. First one will be cyanide leaching, they say. So using this cyanide leaching, I can concentrate silver and gold ores. There is a special name given for this cyanide leaching, that is MacArthur forest cyanide process. இங்கே என்ன நம்ம செய்கிறோம்னா, we are taking a cyanide, usually sodium cyanide or potassium cyanide. Between these two, anyone can be added. The crushed ore, usually let us say take gold ore. So the crushed gold ore is treated with the sodium cyanide. Now what this will do, this will convert this particular gold ore into a soluble cyanide complex. That is the chemical substance called sodium cyanide. As I told you earlier, here it dissolves the ore particles. Yet as a result of that, the crushed gold ore forms a soluble cyanide complex with the sodium cyanide reagent. Here the gangue particles remains insoluble. Here the impurities present is nothing but aluminosilicate. We have an equation for this. That soluble cyanide complex, in this case I can say potassium RO cyanide. This soluble cyanide complex of gold is further treated with an electropositive metal, say zinc. Now what this zinc will do? This zinc will displace gold from that particular complex. So we will get pure gold now. This method is called as, say, cementation method, or I can say just cementation is the name of the process for recovering zinc from the complex of gold. The second method is called as ammonia leaching, or I can say the second example for leaching will be ammonia leaching. Here what you have to understand is that how the name comes for this leaching is that depending upon the reagent that we use. Suppose if I use a reagent called sodium cyanide or potassium cyanide, that will be called as cyanide leaching. If I use, say, aqueous ammonia as that reagent, that will be called as ammonia leaching. Let us discuss about ammonia leaching now. Now using this ammonia leaching, some ore, say for example nickel, copper, cobalt, these ores, the crushed ores of nickel or copper or cobalt is treated with aqueous ammonia. Now what is aqueous ammonia? We know ammonium hydroxide is nothing but aqueous ammonia. That is ammonia is dissolved in water, and that forms aqueous ammonia. So when this crushed ore of nickel or copper or cobalt is treated with aqueous ammonia, we get a soluble complex. For example, when nickel or copper, let us say copper, when copper reacts with aqueous ammonia, we will get a tetramine copper 2 sulfate, a complex. So likewise we will get different complexes for different metallic ore particles. Here what we need to know is, as I told you earlier, the metallic ore particles forms a soluble complex, whereas the impurities, usually here iron 3 oxide or hydroxides, aluminosilicates, these are the gangue or the impurities present. These impurities remain undissolved. So in this way we can explain ammonia leaching. Now the third example is alkali leaching. Alkali leaching, what is meant by alkali? We know alkali, by which you mean bases which are soluble in water, or I can say water soluble bases are called as alkali. Adukku example gavanichina, we can say NaOH, sodium hydroxide or potassium hydroxide. These two are alkali because these two are bases which are soluble in water. Adanal bases soluble in water is called as alkali. Okay. In alkali leaching, I can take an ore. Here the example given is, say, bauxite, aluminium ore, Al2O3.2H2O. So this bauxite ore is concentrated by this alkali leaching technique. சரிங்களா? So this method, you got a name for that, Bayer's process. இதில் என்ன கொடுத்திருக்காங்கன்னா, you got some equations involved. Actually the crushed bauxite ore is treated with aqueous alkali. You have to add NaOH and water, and the temperature that is maintained is around, say, 470 Kelvin to 520 Kelvin, and we have to maintain a pressure of around 35 atmospheric pressure. When this bauxite ore or the crushed bauxite ore is treated with this alkali along with water with this mentioned temperature and pressure, what happens? You got a complex. So that complex is soluble, which is called as sodium metaaluminate. We have different forms of this sodium metaaluminate. In the book you have got NaAlOH4, or even I can say NaAlO2. Nariya formulas irukku the sodium metaaluminate. Just understand, sodium metaaluminate, which is soluble, is the complex that is formed. Now this particular sodium metaaluminate solution is cooled, filtered, and it is neutralized by passing carbon dioxide gas. Now when you do so, what happens is that we get a hydrated aluminum oxide precipitate. This is further filtered and heated, and when you maintain a temperature of around say 1670 Kelvin, we get pure alumina. So this method called alkali leaching, in here we have concentrated bauxite ore by method called Bayes processes. So we have to remember the equations involved here. Next one will be acid leaching. Now in the case of acid leaching, as I told you earlier, constant or say hot, aqueous, sulfuric acid is the acid used here. In the case of acid leaching, some sulfide ores, say for example zinc sulfide or lead sulfide or even copper sulfide, some kind of sulfide ores can be concentrated by acid leaching process. இங்க என்ன சொல்றாங்கன்னா, suppose if you take zinc sulfide, that is the example given in the book, when this insoluble sulfide called zinc sulfide is treated with say sulfuric acid, we will get a soluble sulfate, and elemental sulfur is also obtained. So in this method we can separate some impurities from zinc sulfide ore or some other sulfide ore also is possible. Now in this case of leaching, they say there are many types of leachings are available. That is actually not given in our book. Just for your information, let me tell you, different types of leaching are, say, heap leaching, vat leaching, in situ leaching. You might learn regarding these types in your higher classes. Just for information, I say heap leaching, vat leaching and in situ leaching are the different types of leaching. Now let us summarize what we have learned regarding leaching. See, we have learnt about 4 different examples for leaching: cyanide leaching, ammonia leaching, alkali leaching and acid leaching. And what is the reagent that is used in the case of each leaching? Let me tell you. Sodium cyanide or potassium cyanide will be the reagent used in the cyanide leaching. Aqueous ammonia is the chemical substance or the reagent used in ammonia leaching. And in the case of alkali leaching, it is aqueous alkali, usually NaOH or KOH. And in the case of acid leaching, we have made use of hot aqueous sulfuric acid. ஓகேங்களா? இப்போ இதில் ஒவ்வொரு லீச்சிங்லையும் என்னென்ன ஓரை நம்ம கான்சன்ட்ரேட் பண்ணுறோன்னு பாருங்கள். In the case of cyanide leaching, we can concentrate gold and silver ores, etc. In the case of ammonia leaching, we can concentrate nickel or copper or cobalt ores. Likewise, in the case of alkali leaching, we can concentrate aluminum, that is bauxite ore. And in the case of acid leaching, some kinds of sulfide ores such as copper, zinc, lead ores can be used. And the impurities, you need to know what are all the impurities which are obtained during these leaching processes. In the case of cyanide leaching, we got aluminosilicate. In the case of ammonia leaching, we have got iron 3 oxide, hydroxides and aluminosilicate. And in the case of alkali leaching, we have got iron oxide and titanium oxide. Now, just for information, let me tell you, see, these impurities or the gang particles which you have got during these leaching processes are collectively called as tailings. Tailings. This is new term which you need to know. This is impurity which you have, which is obtained during these leaching processes will be called as tailings. Hope you have understood what I said. If you have any doubt regarding anything, you just leave that in your comment section. Thanks for watching.